Hello, my name is Guy Brown, and I'm Head of Research and Development at AI Build. And today I'm going to be talking to you a little bit about the Medusa project and our involvement in it from the software side. But first, just to introduce us a little bit as a company, what we do, just for those of you who might not be familiar. So we make software for large formats of manufacturing. We've been going for about 10 years now, so a decade playing with these machines. We're based in East London, where we have a lab with 6 or 7 LFAM machines, and we work across quite a few verticals, so automotive, aerospace, defense, energy, construction. We also have some strategic investors, such as Nikon. So the software we make is essentially CAM and process monitoring and control software. But the really important thing about it is that it's about end-to-end automating the manufacturing process for LFAM. So going right from uploading the part when you do your DFAM through slicing, optimizing, simulating, and then doing the process monitoring and in-process control. And so this is really our goal, to do that end-to-end automation through software. But before I bore you talking about software too much, I think it's really important to understand why it matters and what it can do. So these are the types of prints that are possible with our software. So that was one of the ones done in our lab in East London. So very complex 8-axis print, lots of process parameter issues going on, but it was able to be printed very easily and quickly with our software. And it was some process tubing for an energy company. Also on the polymer side, prints like this. So lots of complexities here, but again, made very simple with our software. This was a part for a tidal power company that we actually did in collaboration with the Evo 3D Rapid Fusion guys. Cool. So this is our last slide on the software, I promise. So yeah, I guess the message I really want to get across is that, and what we feel really makes us stand out is, because we've been printing in the lab for 10 years, and we've had a lot of failures, a lot of print defects. All that pain has been kind of had lessons learned, and we've gone and understood the physics and the geometry behind it, and those have gone into our software as features. So the expertise is kind of like baked into the software from those 10 years of experience, and the product really is like a culmination of our pain, so that the customers don't have to go through those same experiences. But what I'm here to talk to you mainly today about is the Medusa. So our involvement in this started from the Innovate UK Evo 1 project, where us, with Rapid Fusion doing the hardware, Filamentive, sustainable materials, and NMIS helping with the hardware, doing kind of simulation, and also on the environmental LCA side. And this is all funded by Innovate UK, so it's a big shout out to them. So at the start of the project, Rapid Fusion kind of laid out these 5 really like high-level objectives that they wanted to achieve for the machine, that they thought would revolutionize the industry, as I think it has. And so we looked at these, and there were kind of 2 to us that really stood out, that said, okay, there isn't software for this, we need to do development for this. And is these 2. So the first one, the fact that it has the automated material and tool changes. So you're swapping from filament to pellet to subtractive, swapping between different nozzles, and obviously there's lots of advantages to this, balancing resolution and speed, and having thicker beads for milling where you need it. And then in terms of a plug-and-play industrial system, so right now in the LFAM market, a lot of the machines are kind of bespoke built to the application, or the customer has to do a lot of work to assemble all these different components and have it integrated together. So having the system plug and play is actually something really new in the market, and really lowers the barrier to entry in terms of the level of expertise a customer needs to get started printing with an LFAM system. So yeah, it's really important. So as I said, we looked at these 2 high-level objectives, and we thought, shit, what do we need to do on the software side to enable this? And so there were kind of, for each of these objectives, 3 key developments that we identified. So on the automated material and tool changer side, having that automated tool changing definition easy to do in the software. Also having a hybrid toolpathing, so doing your additive and your subtractive toolpathing in one place is really important. And also, obviously, the biggest thing is having a tight integration between software and hardware. So your digital twins, post-processor, also having the software actually on the machine. Then on the plug-and-play industrial system side, having a starter version of the software to help people get started quickly, rapid training and onboarding, and also process monitoring and process control, again, to remove the need for expertise for the user. So I'll go into these in a little bit more detail now. Cool, so the first one, so again, this is to achieve that goal of automated material and tool changes. Seems very obvious, but we need to enable automated tool changing. So seamlessly defining where in your part you want to be printed by which tool. So this kind of feature here, I don't know how well you can see it, but the most obvious thing is defining based on your like outer walls, inner walls, skin, the different kind of printing regions, whether you want that to be printed with a filament or pellet or pellet with a different nozzle. So doing that in an easy way is really important. We also have the capability to define different like regions of the part to be printed by a different tool. So for example, if you have the critical surface of a mold tool, normally you want to be printed with like a thicker nozzle with a pellet extruder, so that when you're milling it, it doesn't break through the layers. Or maybe you have an end-use part that you don't want to mill at all and you want better resolution, so you want to print that like critical surface in filament, for example. So this is all now easy to do in the software. And yeah, as I said, this really enables the best of both worlds. So resolution where you need it, and speed where you need it. The other side, the other thing we developed to enable this kind of high-level objective is hybrid toolpathing. So I think it's about two years ago, maybe 2.5 years ago, when we first started talking about this project. And at that time, we didn't have any kind of subtractive toolpathing. So that's something we've since added to the software. So we initially released these kind of 6 modes for subtractive that are basically focused on kind of additive finishing strategies. Like, you know, out of the gates, maybe you're not going to be milling back from a big block of stock, but just milling off a few millimeters of the surface of your additive part, and that's really what these strategies are focused on allowing you to do. The other really important thing is a seamless transition from your additive to your subtractive workflows. So having it all in one place means you're not having to worry about like recalibration of the part. You have the as printed mesh there already in the digital scene, and so that step that would normally be there, that is an absolute pain, having done it from experience, isn't, which is very nice. Yeah. The other side, and the other kind of more unique requirement we have for hybrid toolpathing, because the Medusa is a 3-axis system, normally if you have a really like curved complex surface, you would need a 5 or 6-axis system to mill that. But the workflow we've enabled with the Rapid Fusion guys is to do print mill toolpathing. So you print a few layers and then you do contour milling around those layers, and then you go back to printing. And so that way, even though it's a 3-axis system, you can get the same finishing as a 5 or 6-axis system, which I think is really unique. Cool, and then the final thing we developed for this automated material and tool change objective is the software integration. So firstly, your digital twin, having full kinematic simulation to enable the safety checks. This is important for detecting collisions and accessibility issues, just making sure you're not damaging the hardware, basically. Secondly, the post-processor, so making sure that the paths that are generated are written into the language that the machine understands. And one really important aspect of this we worked on with the Rapid Fusion guys is the tool changing macros. So on different machines, the tools will be in different locations and be in slightly different places. So having like a firmware routine that you can calibrate when the machine is set up, that then is callable by the toolpath is really important for, you know, making sure when the customer gets the machine, it is plug and play. So yeah, that was something a bit unique. Then also obviously the HMI integration for machine slicing is really nice, because, you know, if you're quickly slicing something and prototyping or testing materials, it's quite nice just to have it all in one place and not have to go back to your laptop. Cool. So the second kind of high level goal was around making sure we have the software capabilities to make it as much of a plug and play industrial system as possible. the first kind of important development for that, which is quite a big development, was having a starter version of our software. So in LFAM, a lot of the kind of softwares follow more of a CAM approach that kind of subtractive machining softwares would have. It kind of gives you a bit more control and flexibility to put in user intent, but it also requires a lot more expertise from users. And especially if you're coming from the desktop world where everything is just one-click kind of slicing, that might not be expected and might not be with what you're familiar with. So we added this kind of interface, which is the starter version, one-click approach, to basically help you get to your first print as fast as possible. So that's a really important metric. The way we've enabled this while also having a little bit of flexibility in the strategies is having 9 slicing modes in total. So not just horizontal, but these different kind of common strategies that you might want to do. Yeah. The other really important side of having a plug-and-play industrial system is reducing back and forth. As a customer, you don't want to be emailing all of your different suppliers all the time and having to ask them questions. So having a really rapid training and onboarding that is as automated and self-serve as possible is really important. In terms of the machine setup and integration, one of the great things about the system is that because it's standardized and plug and play, that completely eliminates the software and hardware integration process. That's not something the customer needs to worry about, which is really nice. Then on the other side of that, for the training, that is still obviously there. But what we built is this knowledge center, where you can do virtual training and have courses on how to make the toolpaths. And this is really nice because it allows people to learn at their own pace. Like if you're working at a startup and you need to get things printed next week, you can do an all-nighter, bash through all the courses at once. You're not having to wait for a meeting 2 days later to get your question answered. And this is also really important because it helps this kind of technology scale up. Like if an enterprise orders 10 machines, and they need to employ a load more people to run those. Us as a company aren't having to employ a lot more customer success people because we have this content already. So that kind of helps to keep the costs down for everyone. So the customer's getting a better ROI on their investment. Cool. And then the final thing, and something that's really important for an industrial system, is having the process monitoring and process control side. So this is super critical for kind of, again, bringing down that need for expertise and also enabling repeatable production. So the first thing we've developed and is on that system now is something we call ThermalShield. So this connects to our hub and is basically an infrared camera system that monitors that interlayer temperature and then can adapt the print to make sure your interlayer temperatures are not too hot, so your print's not going to melt down, but also not too cold, so you're getting good interlayer bonding. So this, as an example of in-process control, is really critical for reducing that need for specialized operators. So, if you have a really highly expert operator, they can look at a toolpath, they know what material they're printing with, and they can optimize each layer to have exactly the right speed. But obviously, if you're coming to it fresh and you're just trying to do your first print, this is not something you're going to be aware of. And so having that inbuilt and automated is a really nice thing to just bring down that barrier of entry. And this is something we're planning to add more and more to. The other side of that is the process monitoring. So particularly for your aerospace, your automotive companies, having quality assurance of parts is really important. So both making sure that, for example, in this case, that all of your layers were printed above a certain interpass temperature to basically validate your mechanical strength in the Z direction. But then also, if a part fails in service, having that log and that manufacturing traceability to dig into the data and do a kind of a root cause analysis of what went wrong.
Done.
Cool. So those were the kind of all the things we worked on in the Innovate UK project. And going forwards, we have a tight partnership with Rapid Fusion. So there's quite a few things we wanted to develop. So adding more things to the hub. So 3D scanning sensors for throughput, bed, part alignment calibration. I think there's a lot of optimization we can do around toolpathing strategies for multi-head printing when you're doing full hybrid. But really the most important thing is improving the level of automation and the expertise that's baked into the software, and that's done with process parameter sets for materials. It's done with specific optimizations for the machine, and it's also done with smart defaults. So that's really one of the biggest things we want to focus on, because ultimately tighter hardware and software integration is what is really needed to remove that barrier to entry, to remove that need for the operator to have a PhD in additive manufacturing, and that ultimately is what will unlock LFAM as a key technology in global manufacturing, we feel, which will hopefully look something like this next slide. But maybe with a lot more gantry systems, I think. Cool. So just to wrap up, so we as Build, we make software for end-to-end automated control of large-scale AM. We developed some dedicated software to help Rapid Fusion achieve the goals they'd set out for Medusa. And again, I just want to emphasize that the tight collaboration between hardware and software and integration is really key for making it easy for the end user to make stuff. Cool. So my name's Guy Brown. I'm here with my colleagues Michael, Danny, and Rudy. So please feel free, if you have any questions afterwards, to come up to us. Or I'd also be happy to answer any now if anyone has any. But yeah, thanks for listening.